Hello everyone. My name is Mayank Kushwa and I'm from ABES Engineering College Ghaziabad. As we have already discussed in the previous lecture, in this lecture series we are going to talk about refrigeration and air conditioning, which is unit 3 of the subject Fundamental of Mechanical Engineering, which is designed as per AKTU syllabus for first year students. So in the previous lecture, we discussed about the topics, the syllabus, which we are going to talk about. In this current lecture, we are going to start talking about the introduction to refrigeration system. So refrigeration system is something which we are already familiar with. We have been using a refrigeration system, which is refrigerator or AC, an air conditioning system, since we were a kid, right? So just if I ask somebody to if I ask you to explain this thing in formal words, then you can just tell me that refrigeration system is nothing but a process of achieving and maintaining a temperature which is below the surrounding temperature, which is below the atmospheric conditions, right? Just like our refrigerator, domestic refrigerator, we preserve food, we make colder water, we make ice, we make ice cream in this thing, which is generally preserved, which is made, which is placed at a lower temperature than the surrounding. Right. Similarly, in an air conditioning system, whether it is window type of air conditioning system or a split type of air conditioning system, we maintain a temperature which is much lower than the outer temperature, the surrounding temperature. Right. So I hope you would agree with this definition, which I have mentioned here. So we can simply say that the purpose of doing this purpose of refrigeration could be preservation of food items, maintaining human comfort conditions. Apart from these two, there can be multiple other applications also, such as preservation of, you can say, the agricultural seeds could be there. There can be industrial applications also. We have seen that you must have heard about cryogenics also. The fuel which we generally use in raw, we can say, the robots, the what should I say, rockets, etc. So in those conditions also we require refrigeration system, right? Now, the methods of refrigeration systems that we have developed over a period of time could be categorized into two methods. First one is natural refrigeration system. Another one is artificial refrigeration system. So natural refrigeration systems are those in which we do not use man-made machine for the purpose of obtaining a lower temperature. So the first one is nocturnal cooling. Nocturnal, I hope you already know the meaning of nocturnal. Nocturnal means something which is happening at night. So we all know that at night the temperature is much lower than the daytime temperature. So especially in the area like deserts or hill areas, the temperature is drastically reduced at the night time. So we can use that decrement in temperature decrement in temperature, which is happening naturally, to cool down the objects. Cool down the objects. This is basically nocturnal cooling. Second one is evaporative cooling. Evaporation is, which you already know, is a process in which a phase transformation can take place, like water can evaporate into vapor form. So you must have observed this phenomena that in summer, when perspiration is more, when sweating is more, we feel more cool as we move under the fan. Yes, that is because the sweat evaporates from our body under the action of heat and the air. Similarly, you must have seen earthen pots, which are generally used to keep water colder, right? The matka. So that is because of evaporative cooling. Similarly, cooling by salt solution is also there. So these three types of cooling systems, we do not use any mechanical machines. That's why they are called natural refrigeration system. Similarly, we can use artificial refrigeration systems also, like we have seen in our domestic refrigerator, or we might have seen in an air conditioning system. So these are basically mechanical systems that we use for the purpose of refrigeration, right? One of the most popular, which is employed in these two devices that we have been using since we were a kid, is vapor compression refrigeration system, or popularly called as VCRS. This is what we are going to talk about in subsequent lectures in details also. Other methods of refrigeration system could be vapor absorption, solar energy based gas cycle refrigeration, steam jet refrigeration, etc., etc. Well, as I've already told you that this syllabus, what we are going to talk about is merely the introductory subject. We will be just touching upon this subject as we teach, as we study in mechanical engineering. So these topics which I have mentioned here will not be discussed as they fall beyond the purview of this subject. So we will be restricting ourselves to only VCRS systems. Okay. Now the next important thing which we are going to talk about is unit of refrigeration system, which you must have seen here written TR. So I'm sure you must have heard about this people talking about we have bought 1 TR, 1 ton of refrigeration system. We have bought 1 ton of AC. We have bought 2 ton of AC, 1.5 ton of AC, right? I'm sure you must have heard these type of terminologies in your real life, right? So that 1 ton is basically 1 ton of refrigeration. What is this? When we say it is 1 ton of AC, when we say we have 1 ton AC in our home, we actually mean that it is 1 ton of refrigerations. It is basically 1 ton of refrigeration, TR, which basically represents how much cooling can a system provide, right? So this is formally defined as the amount of heat needed to be extracted from 2000 pounds of water at 0 degrees Celsius. 2000 pounds of water at 0 degrees Celsius to convert it into ice at 0 degrees Celsius in 24 hours. You see? So I think this should be pretty much easy for you to understand. If we have to convert water into ice, then we need to extract certain amount of heat. Yes. So this is what we call ton of refrigeration. So what is the cooling effect that is required? So the cooling effect, which we also called refrigerating effect, is nothing but 1 ton of refrigeration. So what is this? As we can see here, we are converting water into ice at the same temperature. So this will involve only latent heat of evaporation, right? So this is can be calculated as m into L, which I hope every one of you is quite familiar with the formula, where m is the mass of the water, where L is the latent heat of ice. So as we know that mass which is given to here us is 2000 pounds. If we convert it into kg, this will become the mass in kg. And the latent heat of ice can be assumed at 335 kilojoule per kg. So where L is latent heat of ice at 0 degrees Celsius. So which is nothing but 335 kilojoule per kg. If we calculate this value and we divide it by 24 hours, 60 minutes, 60 seconds, then we will get something around 3.5 kilojoule per second or kilowatt. This is nothing but 1 TR. So when somebody says he or she has 1 ton AC installed at their home, it simply means that their AC is going to provide this much of cooling. Their AC will remove 3.5 kilojoule per second of heat from the room, right? This is the amount of cooling their AC is going to provide. Okay. So similarly, if somebody says he or she has 2 ton of refrigeration system installed in their house, it simply means their AC is going to provide 7 kilojoule of cooling per second. Right. Similarly, all the refrigeration systems are measured in this way only. Okay. So the next term which we are going to talk about is coefficient of performance. So coefficient of performance is just like efficiency of a system. This is a parameter on the basis of which we can calculate, or we can compare two systems. We can calculate what is the amount of effect it is producing if it is as compared to the input it requires, right? So for a refrigeration system, we define coefficient of performance or commonly termed as COP as desired output by required input, right? So for a refrigeration system, we know that desired output is nothing but cooling effect. Cooling effect. All we require from our refrigeration system or an air conditioning system is the amount of cooling it provides to us. So this is cooling effect, or this is what we call refrigerating effect. To the work required, right? This is what we mean when we say the COP of a system. Okay. So I guess we can stop here for lecture number 1. And in the next lecture, I shall be talking about a comparison among heat engine, refrigerator, and a heat pump. Please watch the video. And these are some of the references which I have used. Thank you, everyone.